Our planet is alive. It moves, resonates, and breathes. Every ocean tide, every drifting cloud is part of Earth's vast and ancient rhythm. Sometimes this rhythm is gentle, a warm breeze rolling over a calm sea. And sometimes it becomes powerful, fierce, and overwhelming. In those moments, the planet reminds us it is not ruled by human hands. It follows its own laws. One of the most awe-inspiring and devastating expressions of this natural power is the hurricane. These colossal atmospheric vortices can reshape entire regions within hours. To us, a hurricane is destruction. But to the planet, it is balance, an essential part of Earth's climatic machinery. Without hurricanes, the tropics would overheat, the oceans would stagnate, and weather systems would lose stability. Storms carry heat away from the equator, soften extreme contrasts, and maintain equilibrium within the atmosphere. Seen from space, a hurricane is mesmerizing, a perfect spiral of clouds, rotating with mathematical beauty around a calm, dark eye. Yet inside this elegance lies chaos, winds that rival the speed of a jet aircraft and seas that rise like living walls of water. Every hurricane begins the same way, through heat, moisture, and Earth's rotation. When the surface of the ocean warms above 26.5 degrees Celsius, about 80 degrees Fahrenheit, evaporation accelerates. Warm, humid air rises and cools, forming towering clouds. As water vapor condenses into droplets, it releases vast amounts of latent heat, the fuel of the storm. This heat lifts more air upward, lowering pressure at the surface. The cycle feeds itself. If upper-level winds don't tear the young storm apart, a rotating system begins to form. In the northern hemisphere it spins counterclockwise, in the southern hemisphere, clockwise, shaped by the Coriolis effect. What starts as a cluster of thunderstorms can, in a matter of hours, grow into a massive rotating engine stretching hundreds of miles across. A hurricane is not just wind. It is a highly organized structure. At its center lies the eye, a region of deceptive calm. Pressure here is extremely low, and the sky may even appear blue, as if the storm has opened a window into stillness. Surrounding this calm is the eye wall, the most violent part of the storm. Winds exceed 180 miles per hour. Rain falls with such force it can pierce metal sheeting. Beyond the eye wall, spiral rain bands stretch outward for hundreds of miles, delivering torrential rain, lightning, waterspouts, and thunderstorms. The entire system can span more than 600 miles. Cloud tops can reach 50,000 feet, higher than most commercial aircraft fly. Inside these clouds are thousands of convective cells producing lightning at incredible rates. Some hurricanes generate up to 200 lightning flashes every second. Each lightning bolt heats the surrounding air to 30,000 degrees Celsius, hotter than the surface of the sun. The energy of a hurricane is staggering. In a single day, a mature storm releases more heat energy than all the world's power plants produce in a year. A Category 5 hurricane unleashes the power equivalent to 10 nuclear explosions every second. And all of it comes from warm ocean water. A single storm can move hundreds of billions of tons of air and moisture. When a hurricane reaches land, storm surge, the rise of the sea driven by wind, can elevate water levels by 20 to 30 feet, overwhelming coastal defenses in minutes. This was the force that drowned New Orleans during Hurricane Katrina in 2005. Throughout history, great storms have shaped human memory. In 1780, the Great Hurricane of the Caribbean claimed more than 20,000 lives, the deadliest in Atlantic history. In 1900, the Galveston hurricane erased an entire American city in a single night. In 1992, Hurricane Andrew leveled tens of thousands of homes in Florida. And in 2005, Katrina revealed how vulnerable modern societies remain: breached levees, flooded streets, more than 1,800 lives lost, and billions in damage. Yet storms are not only destructive, they also regulate the climate. Hurricanes churn the ocean, pulling cold water upward and cooling the surface. Without this mechanism, the tropics would become dangerously overheated. Today humanity is no longer blind to approaching storms. Weather satellites orbiting 22,000 miles above Earth track hurricanes in real time, measuring sea surface temperatures, humidity, wind speed, and even subtle changes in ocean color that reveal evaporation rates. Hurricane Hunter aircraft, a unique class of meteorological planes, fly directly into the heart of storms. These missions began in the 1940s. Pilots push through the violent winds of the eye wall while instruments record pressure, temperature, and wind speed several times per second. They drop sensing devices called dropsons, which drift down through the storm on parachutes, transmitting data until they reach the sea. These measurements allow scientists to forecast landfall with remarkable accuracy, saving countless lives. Hurricanes are also named, not for drama but for clarity. Before the modern naming system, storms were identified by saints' days or geographic locations. Today, predetermined lists rotate every 6 years. If a storm is exceptionally destructive, its name is permanently retired, like Katrina, Irma, Dorian, and Michael. Storm strength is classified using the Saffir-Simpson scale, from Category 1 to Category 5. Category 1 begins at 74 miles per hour winds, Category 5 exceeds 157 miles per hour. But the increase in damage is exponential. A Category 5 storm can annihilate structures that would easily withstand a Category 2 storm. In recent decades, scientists have seen a troubling shift. Hurricanes are becoming slower but far more intense. The reason is global warming. Warmer oceans supply more energy, allowing storms to strengthen rapidly, sometimes within hours. Modern hurricanes also carry far more moisture. Rainfall during major storms has increased by 15 to 20% since the mid-20th century. In 2017, Hurricane Harvey dumped more than 60 inches of rain on Texas, the highest total ever recorded in the United States. In 2019, Hurricane Dorian stalled over the Bahamas for nearly 2 days, devastating the islands with unrelenting wind and rain. Climate models suggest that by the end of the 21st century, high-category storms may be twice as common. Yet our ability to prepare is growing as well, through stronger building codes, improved forecasting, and early warning systems. After a hurricane passes, silence fills the air. Water recedes, the wind calms, and the world stands still, as if the planet has finally taken a breath. The destruction may seem overwhelming. But life returns faster than expected. Within days, shoots of grass emerge through the sand. Birds return to the shoreline. Fish regroup around coral reefs. Nature rebuilds itself. Even damaged coral structures begin to recover over time, forming new ecosystems. Fallen forests eventually regenerate, giving rise to fresh habitats. For people, a hurricane is a test. For the planet, it is renewal. Understanding this balance allows us not only to survive but to coexist with these forces. Sometimes Earth speaks loudly. Its voice is the crash of waves, the howl of wind, the drumming of rain. And in that sound, if we listen closely, there is no malice, only power, movement, and life. Hurricanes are not enemies. They are part of Earth's breathing, part of the mechanism that sustains climate and life itself. They are born, they change, and they fade away, just like everything on this planet. Perhaps the next time you hear the wind rising, you will remember, somewhere over the ocean, Earth is taking another breath. It is alive, it moves, and it reminds us that the true force of nature is not destruction, but balance. If you are fascinated by the power of nature, if you want to understand how our remarkable planet lives and breathes, subscribe to the channel. More stories about the forces that shape our world are ahead. As long as the wind blows, this story continues.